Hi, welcome to another session of Circuit and Networks. In today's class, under single phase AC circuits, as class 6, we are going to deal with basic problems which are involved in RL and RC circuits. This we are again treating as a class 1 because we have n number of numericals to sort out. So we are going to start with the basic problems and then we are going to enter into the typical and complex problems. So what we have seen in our previous classes that when a voltage is applied across RL series circuit, we have seen that the current is lagging the voltage, whereas in RC series circuit, the current is leading the voltage. So let us apply the analysis of RL RC applied to series circuit with problem 1 as an alternating voltage of 20 plus 30 J. It represents the complex form. In some textbooks, you can see 20 plus 30i. It is also a complex representation. So J, in order to differentiate from a normal instantaneous current, we are taking here as small j. So 20 plus 30J volts is applied to a circuit and a current of 2 minus J amperes is flowing through it. Then what we need to find? We need to find the impedance, the phase angle, power factor, and power consumed by the circuit. So how to start with the problem? We know that the V value is given in rectangular form. Rectangular means it is represented in R plus J X form. R plus J X form. So X is here 30. So we know that when current is lagging the voltage, which is the value given as 2 minus J, this current is lagging the voltage, then it is clearly understood that this is a RL circuit. So when you are going to convert the voltage into polar form, you are going to get 20 plus 30J as 36.05 at an angle 53.09 degrees. Similarly, the current can be converted from rectangular to polar form whose value is 2.236 at an angle minus 26.56. So this clearly indicates that the current is lagging the voltage. Now when you're going to calculate the impedance, impedance is nothing but voltage by current. So the given value of voltage and given value of current are taken in the numerator and denominator. With the help of a normal calculator, you can calculate the value of impedance in rectangular form as 2 plus 16J ohms. So you can also convert this rectangular value to polar value, which is going to give you as 16.12 at an angle 82.87 degrees. Now the impedance value we have in rectangular form as well as in polar form. So what we need to estimate? We need to estimate the impedance. So already impedance, it is obtained in these two forms. So what exactly is the magnitude of the impedance? So the magnitude of the impedance is given by 16.12 ohms. So this is the magnitude value of the impedance. In a normal calculations, you can calculate the value by taking the modulus of z as under root of 2 square plus 16 square, which will give you the value as 16.12 ohms. Then we need to calculate the phase angle. So the phase angle value here, it is 82.87. So this is the phase angle value. So the first two requirements are obtained. Now let us calculate the power factor. So the power factor is given by cos phi. Whether it is RL or RC circuit, it is given by cos phi. So phi is the phase angle and we got the value as 82.87. Just substitute the value of cos 82.87 whose value you are going to get as 0.124 lagging. Why lagging? Because here the current is lagging the voltage. That is why the power factor is treated in terms of lagging. So 0.124 is the value of power factor which is lagging. Now calculate the power consumed by the circuit. So P is given as VI cos phi. So this VI cos phi, substitute the values. We have V which is equal to 36.05, I is equal to 2.236, and we have the cos phi value as 0.124. This will give you the value of power consumed by the circuit as 9.99 watts. In some answers, you are going to get the round-off figure as 10 watts. That is also accepted. And if at all anybody is interested to know in decibel with point values, so it is 9.99 watts. So this is how a basic problem of RL circuit can be solved using the above analysis. Let us go with another example. An alternating voltage of V of t is equal to 189 sine 314t plus 20 degrees causes a steady current of I of t which is equal to 12.24 sine 314t minus 40 degrees. Now you can see this is V of t and this is I of t. Now what we need to calculate? Here we need to obtain the value of power factor and average power delivered to the circuit. So we need to find out these two values. So how do we do that? Let us take the value of the given information, that is input voltage and input current. Mind here, this small v of t represents the instantaneous value of voltage, whereas small I of t represents the instantaneous value of current. So here you can see 189 and 12.24. These are the maximum values, and you have sine omega t. Instead of omega, you have 314. So omega is equal to 314 t, where it is called as angular frequency, plus 20 degrees. Here also you have omega t, that is omega value is given as 314 t minus 40 degrees. Again, it is clearly visible that we need to find out the value of phase angle, that is minus 40. This is the value of current, minus 20. So minus 40 we are taking as it is, minus 20, that is a phase shift between the voltage and current. So it is minus 40 minus 20, which will give you as minus 60. So this is how you estimate when the like values are given in terms of the instantaneous value of voltage as well as the instantaneous value of current. Therefore, the phase angle between these two parameters is minus 60. Once we obtain the value of phase angle, we can easily obtain the value of power factor. So the power factor is equal to cos of minus 60. Cos of minus 60 or cos of 60 will give you the same value, which is nothing but 0.5. So this is the value of power factor for the given problem. I hope you understand this. Then we are going to calculate the average power, which is given by P average is equal to Vrms Irms cos phi. In some text, like in our previous problem, in problem 1, it is given as Vi cos phi. V represents the value of the voltage, and whose value is nothing but RMS value. So either it is V or Vrms, this is one and the same. It is obtained as Vm by root 2. Vm is the maximum value of the voltage divided by root 2. So whether it is V or Vrms or Vm by root 2, they are one and the same. Similarly, I or Im by root 2 are one and the same. So Vrms is equal to Vm by root 2, Irms is equal to Im by root 2. So these values are the RMS values and represented in terms of maximum values. So it should be Vrms is equal to Vm by root 2 or Irms is equal to Im by root 2 cos phi as it is. So substitute the values what we have. So we have maximum value of voltage over here 189 by root 2. The current 12.24 divided by root 2 multiplied with cos phi, that is nothing but cos phi, that is cos of this angle, phase angle is nothing but 0.5. So substituting the value as it is, I'm going to get 578.3 watts. So this is how we solve this kind of problems. I hope you understand how we are following the analysis of RL circuit. Now in another example, you can see an alternating voltage of V of t is equal to 10 sine omega t plus 20 degrees causes a steady current of I of t is equal to 12 sine omega t plus 40 degrees. So unlike the previous problem, you can see V of t and I of t. In the previous problem, we have V of t, the value is the same. The value is, in fact, is the same. The values of magnitude and angles are somewhat changed. And in terms here, omega is given. In the previous problem, it was 314. It is given. Whereas the current, it is designated by plus symbol. So how you treat this value? So here, plus indicates the current leads voltage. Okay, what is the requirement? We need to calculate reactance, power factor, and power. So how do we do that? First, take the values of instantaneous voltage and instantaneous current. It is given from the given problem. Just change the instantaneous values in terms of RMS. So RMS is equal to Vm by root 2. I told you that. So Vm here it is 10 divided by root 2, and representing this rectangular in terms of polar. So it is simply at an angle 20 degrees. I hope you understand how I changed this instantaneous value of voltage to the RMS value of voltage. Okay. Similarly, convert this I of t to RMS value of current as 12 by root 2 angle 40 degrees. So I is equal to 12 by root 2 angle 40 degrees. So this is the instant value of voltage, instantaneous value of current. Change it to RMS value of voltage, RMS value of current. Now once we obtain voltage and current, let us calculate the impedance. Why need to calculate the impedance? Because impedance has the reactance part as well as the real part. The real part is resistance, and reactance, it is due to the capacitive nature of the circuit. So it becomes capacitive reactance. So in fact reactance we need to find out here. To find out the reactance, we are finding out the impedance. So impedance is equal to V by I. Just substitute the value of RMS value of voltage, RMS value of current. So RMS value of voltage is 10 by root 2 at an angle 20 divided by current, which is 12 divided by root 2 at an angle 40, which is going to give you the value of impedance in polar form as 0.833 at an angle minus 20 degrees. Don't get confused with this minus. Stick to the problem. Here in the problem, I of t, it is plus, whereas V of t, it is also plus. And you have sine terms same, angular frequency same, and just concentrate on the positive signs of the voltage as well as the current. So here the current leads voltage. Hence it's a RC circuit. So how do we convert this in terms of reactance? Let us see now. So just change this value of the polar form into rectangular form. Polar form is changed to rectangular form, whose value is 0.783 minus 0.285 J. Now this represents R minus JXC ohms. So this is the value of impedance for capacitive reactance of the network in RC circuit in series combination. So Z is equal to R minus JXC. If at all you want to know the value of impedance of the circuit in magnitude form, so the impedance of the circuit in magnitude form is equal to 0.833. So the impedance of the circuit can be obtained directly from this observation. Now we have concluded that the given problem is RC series circuit supplied with AC input, and Z is equal to R minus J XC, and the values which we got in terms of rectangular form, which is equal to 0.783 minus 0.285 J ohms. Now what is the things which we require? We require XC. So XC is the reactance of the circuit. R is the real component of the circuit, that is resistance 0.783 ohms, and reactance is 0.285 ohms. So this is our first requirement. Then power factor, I told you whether it is RL or RC, it is cos phi. Substitute the value of cos phi, that is cos of minus 30. which is equal to 0.866. So it's a RC circuit. So current leads the voltage. That's why it is mentioned here as leading. Then calculate the power. We know that power is equal to VI cos phi. So substitute the value of V, substitute the value of I. So V is the RMS value, I is the RMS value. Vrms is equal to Vm by root 2, 10 by root 2. Irms is equal to Im by root 2, 12 by root 2. Cos phi value we got as 0.866. So this will give you the value of power, which is equal to 51.96 watts. So this is how we solve the basic levels of series RL and RC networks connected to AC inputs. In our next classes, we are going to see the choke coil problem as well as RC and RL in complicated areas. And then we are going to see the combination of RLC in series combination, and then finally RLC arranged in parallel combination, series combination, and combination of both series and parallel. So thus that is going to conclude with our single phase AC circuits. I hope you are understanding the entire concepts or the basic concepts whatever we have did so far in our regular classes. So in order to give you much more information about single phase AC circuits, the problems related to RL, RC, whether it is complicated problem or next level problems, you can please chat in the comment box and like my video, share among your friends, subscribe to my channel and press the bell icon for the future notifications.